We're going to do a deal with Mr. Al-Khalili today. And what are we going to talk about? Well, we're going to talk about Big Bang, the origin of the universe. Did that ever happen? Well, if you ask general relativists, they'll say that it did 13.7, 13.8 billion years ago, Earth years ago, right? No God, no magic wand. It did it all by itself. So that's the story today, okay? So if you got something better to do, well, then don't do it. Stick around, you might learn something. Okay, so where do we start with good old Al-Khalili? Well, he starts out his presentation, his dissertation, saying, the moment 1/1,000,000th of a second after the universe sprang into existence. This was the moment of that Big Bang, which is, many people say, well, it wasn't really an explosion. So I don't know. They call it a Big Bang. They illustrate an explosion, but they say it wasn't. And you try to figure that out. It's not like, you know, the way they illustrate is like a hand grenade, you know, wham. And then they say, well, you didn't see a hand grenade. Okay, a time before matter itself formed in any way that we would recognize it. It's as close as we get to what? Creation, the beginning of time. What did he say? He said creation. Sounds like he's a creationist. Could that be? Creationist? A mathematical physicist? A creationist? An atheist? A creationist? I don't believe it. I refuse to believe. And so, just in case, he continues, says, the question, where does all this come from? Yeah, where does it all come from? And for most of human history, he says, the answer to such apparently simple questions could only be attempted by religion. Okay? It wasn't until the middle of the 20th century that science built a coherent and persuasive creation story of its own. Science proposes creationism, what the traditional religions, some of them, or most of them maybe, have proposed all these years. And the mathematicians all the way from, maybe the 17th century onwards, they just kept fighting that notion, said, no, what the Bible says is nonsense, it's not true, you guys are a bunch of idiots that you believe in the Bible. And now these people are saying the same thing, but they say now we have scientific proof. Scientific evidence, right? It was a story based on theory, predictions, and observation. That's how they determined scientifically, through those elements. Okay? It's a story that could finally explain what happened at the very, beginning of time, the beginning of the universe itself. Talk about creationism. Yeah, so all we have today, whether you go to your church on Sunday or to your pastor, whatever, or you go to the university, you're going to get a creationist theory that the universe, matter, appeared somehow, in the case of mathematical physics, out of nothing. And in the other case, out of the wand of God, magic wand of God. Those are your two options. That's in the religious and so-called mathematical physics world. And now maybe you get an idea why I put mathematical physics under religion as well. They're all creationists, okay? Never crossed their mind that matter cannot convert into space, space cannot convert into matter, therefore matter has always been there because it cannot escape that which has no borders, also known as space, right? Space is nothing. What is nothing? That which has no borders, that which has no shape. And you cannot escape nothing. Not even God can escape nothing. Okay, so if you cannot escape nothing, matter cannot escape nothing, an atom cannot escape nothing because there's no boundary to cross, then matter has always been here. That's how simple the reasoning is. And it took 10,000 years for that. I don't know why. Okay, and here are some prominent atheists. Okay, they voiced their opinion. Here you have one, Victor Stenger. He died a couple years ago. He was a professor at the University of Hawaii, somewhat popular. Okay, everyday experience and common sense supports the concept that something cannot come from nothing. Yeah. However, common sense is often wrong So if you have common sense, you're wrong, you know. And our normal experiences are but a tiny fraction of reality. If you want to be an atheist, you must put your common sense on the shelf. Absolutely love that, okay? Richard Dawkins, more famous, more known for to a lot of people. The fact that life evolved out of nearly nothing, some 10 billion years after the universe evolved literally out of nothing, is a fact, right? So staggering that I would be mad to attempt words to do it justice. Here's an atheist boasts about, you know, atheism, how the Bible is wrong, and all these traditional religionists are out of their minds. What does he propose? Creationism. Where did he get that? Well, he got that out of the mathematical physicists who claim to have proven through evidence that the universe sprang from nothing. And that's what he believes today. He calls himself a rational person. He calls himself an atheist. Now you see another reason why I abandoned atheism. Now, atheism is unscientific. Why? Because it's based on evidence. In science, we do not use evidence. Evidence is what you use to convince, persuade the jury. You're harping on their beliefs. You're trying to change their opinions, their perceptions, their way of thinking. That's what you use evidence for. That's why we don't use evidence in science. Science had better be objective, and for everybody on Earth, it should be the same. You should look at a mechanism up there on the wall, on the screen, and wherever, and you should be able to understand the mechanism. That's objective. Whether you believe in that mechanism is a secondary issue. But the mechanism is objective in science. In religion, it's where we believe and choose and say, oh, I like this theory and not the other one. That's why we do not use evidence in science. We do not prove in science, because prove means that I convinced you of my theory. That's all that evidence and proof and all that stuff means. Those are not elements of science. A lot of people say, what do you mean we have proven, we have evidence? No, not in science. That's in religion. That's in your Sunday school. Okay, here's another statement. This one from our good friend Stephen Hawking. At the Big Bang itself, the universe is thought to have had zero size and so to have been infinitely hot. Okay, there are something like 10 million, they go through all these millions, you know, particles in the region of the universe that we can observe. Where did they all come from? The answer is, in quantum theory, particles can be created out of energy in the form of particle-antiparticle pairs, okay? But that just raises the question of where the energy came from. Yeah. And the answer is that the total energy of the universe is exactly zero. So we came from absolutely zero, okay? That's what he's saying. The matter in the universe is made out of positive energy. That's matter. Matter is made of positive, right? The gravitational field has negative energy. So we have matter and gravitational field. One is positive, the other one is negative, okay? That's what he's saying. In the case of a universe that is approximately uniform in space, one can show that this negative gravitational energy exactly cancels the positive energy represented by the matter. So the total energy of the universe is zero. Now, twice zero is also zero. Well, I'm glad he knows his arithmetic. Thus, the universe can double the amount of positive matter energy and also double the negative gravitational energy without violation of the conservation of energy. When the universe doubles in size, the positive matter energy and the negative gravitational energy both double. So the total energy remains zero. The universe is the ultimate free lunch. That's how they're explaining the creation of matter from so-called nothing. They just take two concepts called gravitational and matter energy, or whatever they call it, okay? And they have these two energies, which are concepts, abstract concepts, mathematical concepts. They have nothing to do with physics. They're putting them together, positive with negative. They cancel out and they have zero. So that's the starting point. That's your zero. From there, you can separate one from the other and create matter on the one hand and gravitational energy on the other. That's their explanation. Now, what do you think of that? Okay, and just in case, one more. We got to make sure we got all the authority behind us we can get. And here's this fellow who trying to push his book, A Universe from Nothing. He's been trying for the last 8 years. And what does he discuss in there? He says, I have focused on either the creation of something from pre-existing empty space or the creation of empty space from no space at all. Okay? The only problem, in his book, like I covered him in the past, is he doesn't define what space is. He doesn't define the word universe. Okay? So we don't know what he's talking about because he doesn't define his key terms, which is typical in mathematical physics. They assume you know what you're talking about. I mean, if you're going to say something important like, that the universe came from somewhere or did not come from somewhere, as a minimum, you want to define the word space, universe, matter, what an object is, what a thing is. They don't do that. They just take the words, those notions of ordinary speech, and they assume you know what they're talking about. That's the starting point. That's why I harp on semantics, as some people like to dismiss it. You got to harp on semantics because these people are getting away with murder because they don't define their terms, because they're doing semantics. Okay, so one of the issues that came up was the size of the universe. This was until the early 20th century. They were trying to figure out what the size of the universe, how big is this universe? Remember, those days they didn't have such powerful telescopes that we have today, orbiting the Earth and so on, like Hubble. And so they were trying to figure out how big the universe was. They had these big monster telescopes in those days, probably refractors. And so the question was, what is the size of the universe? And by the beginning of the 20th century, right, they had figured out more or less that solar system lay within a galaxy. So we were somewhere in a galaxy. And one of the guys who contributed to that understanding was Edwin Hubble. Okay, he's the guy who was able to demonstrate that the Andromeda nebula, which looked like a little cloud, a little smudge in the sky, was really a galaxy that was very, very far away. It wasn't a star like others that you could see a lot more sharply. This one was a little nebulous. That's why they're called nebula, which means cloud in almost in every language, Latin language. And so you could see it almost like a faint cloud. And they said, what is that? And one way that he figured out was through the Cepheid variables. These are stars that change their brightness. Okay, and it was located inside that nebula. And so they said, look, with this star, if we can determine how far that star is, we can determine where this nebula is. And when he did his brightness test over a couple days, right, really over a month, he took 31.415 days, in other words, 31 and a half days. That's when the peaks of that star, that Cepheid variable, went from maximum, went down again, and then back to maximum. It took 31 and a half days to do that. And between the brightness and the period, he was able to figure out the distance of that star. And since the star was inside the Andromeda galaxy, he was able to figure out that the Andromeda galaxy was very far away. He did some calculations. He figured it's very far away. How far away? Well, he figured out it was 900,000 light years away. Traveling at the speed of light, it would take you 900,000 years one way to reach the Andromeda galaxy. Sometimes I think these guys do a lot of faking. Why? Because the Andromeda galaxy today is said to be 2.5 million light years away. Maybe they missed it by a million or something, I don't know. But it's twice as big as, or more than twice as big as what Hubble calculated. Now you say, how can there be such a difference among mathematicians? I mean, if he measured maybe 10% off at the most, maybe 5%, 1% would have been great. He missed it by more than 100%. It's twice as much. So I don't know. I think maybe Hubble, like so many other of these mathematicians who do so perfect calculations, I think they kind of cheat and they try to fit the numbers to what their preconceived conclusions, what they come up with first, and then they say, well, let's see if we can fit the numbers to match the what we observe. I think a lot of the times it works that way. Keep that in the back of your mind. anyways, still some problems arose, okay, because you had to explain one of the issues that was brought up by Newton already 400 years ago. And that was, why doesn't all the matter in the universe, if it's got all this gravity, pulling it, object attracts object, according to his equation, mass attracts mass, why doesn't it all come together in one lump? And so Newton tried to answer that question in a letter to Bentley, Penzias, he wrote, if the matter was very diffused through an infinite space, it would never convene into one mass, but some of it convene into one mass and some into another, so as to make an infinite number of great masses scattered at great distances from one to another throughout all the infinite space. He was essentially giving you a definition of the word galaxy. He was saying, we have all these galaxies, and they have all these power centers, and that's why they don't all come together. And the only thing I'm going to add to that, to Newton's notion there, is that if all these galaxies are rotating around the universe, they maintain their separation. They don't coalesce into a single point, because not like Pluto doesn't coalesce to the sun because it's rotating around the sun. And I'm saying something similar is happening to the galaxies. Not only do they have this mass that's spinning around locally, but the galaxy itself is spinning around something else as well. And then you have the local group, we have like 50 galaxies in our region of the universe, and those are probably moving together with respect to some other galaxies that we can't even see. So I think it's all rotating or whatever. Maybe it's rotating up and down or in different directions. And that's why also all this matter does not come together to a single point. Okay. Anyways, Einstein disagreed with that. He said the attraction of gravity from all the matter in the universe would pull every object in the cosmos together, accelerating until gravity would ultimately and inevitably lead to collapse of the universe itself. Okay. But Einstein didn't believe that the universe was likely to collapse upon itself. These are words from Al-Khalili saying what Einstein was thinking. He's saying he didn't believe in this dynamic universe. He believed in a static universe, more or less, and nothing really moved. Remember talking about the beginning of the 20th century. We didn't have as much information at the time. And he did not believe that, that the universe was that dynamic. And so in order to compensate for it, to try to explain why all the matter does not come together and form a single lump, Einstein invented what is known as the cosmological constant. Okay, he put that in his equations, and that kept the universe in a static mode. Okay, and it was kind of like an artificial fix to get that universe to be in a steady state. Okay, that was the reason for that cosmological constant. Well, what happened was that fellow approached him. He was a priest, Belgian priest, and he says, "Look, the universe is expanding. All the galaxies are kind of pushing away from each other, and if you take the movie backwards, well, at some point they were at a single point. All this mass was concentrated at a certain point." And guess what that was? That was the famous Big Bang. That was God making that point for us. He's eternal, but the universe started when it came out of God's magic wand. Well, Einstein didn't like his proposal, and they met at the 1927 Solvay conference. This fellow Lemaitre, he kind of ambushed Einstein because he wasn't in the meetings, but he came with his ideas. And when he found Einstein, he decided to talk to him. And what he was proposing was, this dynamic universe. And Einstein dismissed it altogether. And as a result, Lemaitre had a very, very bad opinion about Einstein after that. And so nobody paid attention to this fellow Lemaitre because he wasn't backed by anyone of importance, okay, like Einstein or Bohr for that matter, right? And so his so-called primeval atom, where everything started, kind of died, and it was resuscitated sometime later. Okay. And so who resuscitates it? It's this fellow, Edwin Hubble. He took that problem as his own. He started investigating. And what Al-Khalili tells us essentially is Hubble noticed the relationship between the distance of a galaxy and how fast it is moving away from us. Okay, there was a relation there, according to Hubble. And based on the concept of the redshift, Hubble calculated the speed at which galaxies were receding. Okay, and the further they were, the faster they were receding. So the farther away this galaxy was, the faster it was moving against from the Earth, at least, like if we were the center of the universe. And he could determine that through the redshift and blue shift. Okay, and yeah, I'm not going to go over that. It's for those who understand the Doppler shift. That's what it's got to do with. Okay, he blessed Lemaitre. Okay, Edwin Hubble did. He got on the side of Lemaitre, saying, "Hey, you know, the universe is indeed dynamic, and all the galaxies are receding from each other." And he calculated the speed at which they were receding, and he realized there was a relation that the farther they were, the rather the shift, okay, which means the faster they were running away from us. So Einstein lost the battle, okay, and today it's he later on he admitted that or that's a story today, that he admitted that the cosmological constant that he had created to put in his equations to keep a steady state universe, he said it was the biggest blunder in his life. Okay, I think the biggest blunder was introducing space-time, which he didn't all by himself, but that was the big blunder. Okay, no such thing as a monster called space-time. Okay, so here we have modern versions of this expansion. Okay, here's one fella, and he's a professor at UCLA, and he says the following. He says, the expanding balloon analogy. Remember, you got to find out why these galaxies are receding from one another, and what they're saying is space is expanding. Okay, there's this balloon of space, okay, and it's expanding through time. Remember that, through, the word through, and when it does so, it pushes all the galaxies apart. That's essentially what he's saying. But you say, well, what is expanding into? What's the white stuff that surrounds that balloon? That's what you want to know, right? And he's got an answer to that. He says, look, the balloon analogy is a two-dimensional model. Okay, that's a 2D model. You can see there. 3D projection onto a 2D platform, okay? And he says the center of the balloon and the space around are not part of the two-dimensional universe. In our three-dimensional universe, these points could only be reached by traveling in a fourth spatial dimension. Not the time dimension of 4D space-time, but there is no evidence that this dimension exists. In other words, in this 2D universe that you see there, 2D flat universe, right? The white stuff is an object. He treats it as an object. So he said, or you're supposed to treat it as an object. You're saying, what is the balloon expanding into? Well, it's against that white stuff. But he says, what you're doing is you've got a two-dimensional drawing here, and the space there, or the white stuff, right? You can't see it from a two-dimensional perspective. And if you're in 3D, you got the same problem, because you would have to have the fourth dimensional space. The space would have to be in a fourth 90-degree angle to our 3D in order to see what we're expanding into. Because we are expanding supposedly not into a three-dimensional space. That's what he's saying. We're expanding into a fourth dimensional space. He says that we have no evidence that it exists, but he's postulating it anyways. He's saying that's what we're expanding into, okay? And he says we can't see it anyways because it's a fourth dimensional space. And he says essentially that we're not talking about a time dimension, okay? He's saying you're talking about a fourth spatial dimension. So what is the problem with this? Okay, the problem with this, and here it is, I got to use authority because people will say, Bill, you came up with this. No, I just point out because I do research which nobody does, and they don't catch these things which are very important to destroy arguments like the one you just heard. Okay, and here it is. It comes from Mr. Hawking. Okay, just before he died, he wrote a book, A Brief History of Time. He says, in relativity, There is no real distinction between the space and time coordinates, just as there is no real difference between any two space coordinates. I hope you understood that. That means what this other guy was saying is nonsense. Okay, because he's saying, oh, there's a fourth spatial dimension, we can't see it, and that's what surrounds our three-dimensional space. This guy is saying there's no difference between a time dimension and a space dimension. So if we can talk about traveling through time, the expansion through time, in the same way we should be able to talk about expanding through a fourth dimension. And this guy says there's no evidence of that, even though they claim to have a proof evidence of a time dimension. They don't have a proof of a fourth spatial dimension. So you see, they have a contradiction there, a major contradiction. But nobody catches these things. Nobody cares. Nobody does any research or confronts their contradictions. Okay? For instance, instead of measuring the position of a point on the Earth in miles north of Piccadilly and miles west of Piccadilly, one could use miles northeast of Piccadilly and miles northwest of Piccadilly. Similarly, in relativity, one could use a new time coordinate. That was the old time in seconds plus the distance in light seconds north of Piccadilly. So he says all these things are interchangeable. So there is no excuse to say, well, we can't see a fourth spatial dimension. And again, this fellow from UCLA, right, he says we have no evidence of it. Then if he has no evidence, he cannot say, all he's done is elude the question. What is our universe expanding into if it's expanding? He's got to tell us what's on the other side. He's got to name it. He just said it's a fourth spatial dimension, whatever that is, and we have no evidence, so don't ask the question again. That's what he's telling you. Okay, so it dies there. And then the other guy says, well, there's no difference between any of these dimensions. So if we can see or sense or feel the time dimension, we should just as well feel the fourth spatial dimension. So they have a contradiction, no doubt about it. Okay, what else do these people say? Well, here you have some statements, and these are so ridiculous I don't even want to read them, but I'll do that just to hurt your feelings if you're a relativist, okay? The number of photons is, and this guy is from, what is it, the and what is it? I lost it's one of these accelerators, okay? And can't remember its name, but I'll probably remember either today or next time. It says the number of photons is a conserved quantity. It doesn't change as the light travels, okay? So light is traveling, right? It doesn't change the number of photons, right? If one did live in a vastly ancient universe, then light could travel for long enough that every line of sight would end on a star. He's trying to explain Olber's paradox. He says the reason we can't see the light from every star in the universe, which should be, the whole night sky should be lit up. You should see, in every direction that you're staring, you should see a light. And he's saying, look, the reason we can't see it is that the universe is expanding, okay? And so whatever's emitting that light is traveling faster than light travels to our eye. That's essentially what he's saying. So as the universe expands and pushes everything outwards, light can never reach us from that point, from that source. That's what he's saying, okay? And here you have more of that. Objects more than 13.7 thousand million years ago, in other words, 13 billion years ago, right? The moment of the Big Bang, are too far away for their light ever to reach us. They're just too far away, okay, he's saying. Well, what do they mean by that? Well, if there's an expansion, it keeps getting further and further away, and that light will never reach us. Somehow, the expansion of space prevents light from going faster than the expansion of space. Okay, that's what they're saying. Last one here, from a book from Kaufman, very popular book within physics. We cannot see anything beyond the cosmic particle horizon because the travel time for light coming from these incredibly remote distances is greater than the age of the universe. Okay, you see what they're saying? What's the problem with all this? Why is this all so much poppycock, so much nonsense? I call it the candle in the wind. Okay? Let me explain it first, then show you the little picture. You ask your neighbor, your friend, to go with a candle. You light up the candle, and the guy goes, you're on a mountain, for example, right? And you say, okay, go to the valley so that I can see the whole world from here, right? Go to the valley with your little candle and keep going farther and farther and farther away, and I'll keep in contact with you through my walkie-talkie or through my cell phone or whatever, right? And you have a little tube, not a telescope, just a tube, and you're looking at the little candle he's holding in his hand, okay? You're staring at the candle, okay, the flame. He walks away very far, and at some point, you can't see the flame anymore. He's too far away, and you just can't see the little light of the flame. Okay, you got that so far? Your friend goes with his candle. He goes so far away, you can't see the flame anymore through the little tube that you're looking. It's just a little tube, not a telescope. So at the point where you can't see it anymore, you give him a call and say, okay, stop, Joey. Stop. I can't see the flame anymore from that distance where you are now. Okay, so far so good? The idiots of mathematics, the idiots, that's the correct word. I'm sorry. I'd like to call them something better, but that's, if you want to treat them with respect, you got to say idiots. The idiots of mathematics are saying that if you stay long enough, the photons will eventually come into your tube and you'll be able to see the flame. That's what these people are saying. Now, in the case of the universe, they say, well, we can't see it because the universe is expanding and pushing the sources away. Well, what's the trouble with their theory for the candle in the wind? You got this candle there. You put it on a table. It's not moving anywhere. You got the same distance all the time. Why can't you see all those photons coming through your tube into your eye? Okay, so this is the problem. And here's the picture of the candle in the wind. Okay, you're at the horizon. You can't see it any longer. What relativists predict is that you stand a long time. At some point, the photons will start coming into your eyes. That's what they're saying. That's their argument. That's their theory for why the night sky is black. They're saying that light has not been able to travel to your eyes. Okay? So keep that in mind. That's their argument. Okay. Al-Khalili continues, and he says one of the things we had to do was, let me get this bigger here. It says the problem that the Big Bang raised, the expansion, it raises many questions that answered. Okay, and he says, like, if the universe had sprung from a single point, where did all the matter come from? Yeah. But for that, you had to know what the universe was made of. Okay, and the studies indicated, by studying the sun especially, they were able to determine that most of the matter in the universe, they studied other stars as well, they said most of the matter in the universe is 98%, over 98% is hydrogen and helium. He says most of it is hydrogen and helium. Why? They look at the spectrum and they are able to determine what chemical elements are in that spectrum. And they saw the big peaks for hydrogen and helium and very tiny peaks for all the rest of the matter. So he says, then the question was, okay, now we figured out what the matter in the universe is made of. How did this helium and hydrogen come to be? What created it? How come we have 98% helium and hydrogen in the universe, and the rest in the solid matter, so to speak, so little, so just less than 2%. And for that, they had to study how the sun worked and what the sun was doing. And eventually they figured out that, the sun was compressing through these nuclear processes, was compressing hydrogen to helium, helium into higher, more massive elements. Okay, that's what they came up with. One of the guys who worked on that was this fellow, George Gamow. He was Russian, but he became a U.S. citizen. And one of the things he tried to figure out was how this matter originally came to be. How did the universe create this matter? And through this Big Bang, he was working on that thing, and he looked at the sun, he looked at the original explosion in the universe. He concluded that the mathematical model of the early stage of the universe, that atoms could not exist then. At that moment in time, there was just too much heat, too much pressure. There couldn't be atoms. only parts of atom, parts that are going to form the atom eventually, okay? And what we know today is quarks and gluons. Essentially, that's what he was referring to. But he had this idea at the time. They had no ideas of quarks and gluons. He said, you know, there could have been atoms right after the Big Bang. This took some time to form these atoms, to, you know, construct them, okay? And just as the parts that make up the atom, superheated primordial super protons, neutrons, and electrons. Okay, you couldn't have that, at least not in an atom. Okay, and but he says the explosion should give you an idea that there's got to be this radiation in the background of that initial explosion, almost 14 billion years ago. And it turns out in 1964, Penzias and Wilson, two guys who were doing something else, they discovered it by mistake. You know, they discovered some faint signals that were in the background, and the mathematicians inferred from putting these two guys together, Gamow with what these guys discovered. They put it together and they said, look, all that noise that you hear in the background that you can't get rid of, any way you point your sound and whatever detectors you have, all those come from the original Big Bang. That's the background radiation that you're sensing there. Okay, and they calculated it has to be around 3 degrees Kelvin, 3 degrees above absolute zero, essentially. Okay? And it's known as the cosmic background radiation today. Okay, so that's how they came up with this stuff, and that's how they prove. These are proofs, evidence that they collect. Evidence, you know, evidence to convince you. And these are things that they come up with, and they say, look, well, we think our theory is sound because we detected the background radiation, okay, 3 degrees Kelvin, and we expect that from the explosion, initial explosion, and then all we got to figure out is how these atoms constructed themselves and at what point in that whole sequence, okay? So they were starting to pick up what they call evidence, okay? And so Jimmy comes in there and he tries to explain some of that. Or at least he tries to figure out, tries to tell you the story of how it all came to be, okay? So where did all the matter come from, and how do you get something from nothing? Yeah. I wish I knew how to do that. A lot of people would like to know that. The answer to these questions lie further back, hidden behind the curtain of the cosmic microwave background radiation. In other words, he says it was hidden behind that. We need to look behind this curtain of the CMB that's there, and then we'll find out how all these things were constructed. Okay, he says their secrets lie in the primordial universe within the very first second of its existence. So 1 second after, I mean, we're talking about seconds and microseconds. That's what they're going to be talking about. If you can go behind that 1 second where that radiation maybe started popping out, okay, if you can go behind that curtain, then you're going to find out how these atoms were constructed, okay? And so this is where they get into the millionth and billionth of a seconds, okay? That's all calculated. Okay, it says this is the moment in which the quarks are trapped by the gluons. Remember, the quarks were these little balls that form the protons and the neutrons, and what holds them together are the little beads known as gluons that look more like, what, bed springs, as I showed you, okay? It says trapped by the gluons to create protons and neutrons, the confinement of the quarks. That's what they call it. So once you confine the quarks through these gluons that go between them, now you have an atom. Or you have at least a proton, okay? The electron, well, that comes later. Somehow those were whizzing around, some gluon that got lost or a quark that got lost, okay? And so they're talking about 1/1,000,000th of a second right after the Big Bang. That's the time frame. So now we're talking about billions and billions and billions, like Carl Sagan would say, okay? And so how do we detect this? How are we going to prove that this happened behind the wall of the CMB, this curtain that's not allowing us to see there? And so he says, look, we have some questions to answer. One is how matter itself condensed from a fog of energy, energy being a concept. So he's saying that from this concept we created matter, okay? How mass is generated from the force that binds protons and neutrons together, okay? And we don't have answers to that, they say, okay? And how the universe itself underwent a super fast expansion expansion in 1 billionth of a second to create the structure of the cosmos. And he says to figure that out, to find out what's behind that CMB curtain, he says we're going to need to build a bigger collider. We need to collide these things because we figured all these things through collisions, and now we need more collisions, but we need more powerful, more high energy collisions in order to see how the original universe got started. Okay, behind that curtain of CMB that doesn't allow us to see those billions of billions and billions of a second, or what happened before, right? And he says, in order to do that, you need an accelerator with a circumference larger than the orbit of Pluto. So now you see where your future tax dollars are going to go. They're going to build an accelerator that's got the size of the orbit of Pluto, and they're going to accelerate particles there at great speeds, or so I guess this is the plan. And they're going to tell you how the universe got started. Not what came before the universe. That's God, probably, or we don't know, or that's beyond the realm of science because we can't prove it. They'll give you some answer for that. But they just want to get to the almost zero, which is a billionth, 4 billionth of a second. They want to know what happened then. And for that, they need this big collider. So please be generous and contribute to this project. Okay, someday they'll have it. Okay, here are my conclusions of what Al-Khalili says. He claims to be a rational individual. He's a physicist, and that's as rational as it gets, right? And he's an atheist because he's rational, right? Okay, all atheists are rational people. But Jim believes in self-creation. He believes in creation from nothing. Traditional religions, God is the creator. Here, there is no God. They get rid of God, but they keep the magic wand. And so what happens, you create something from nothing. Okay? How they do that, I don't know, because I can't imagine the frame of the film where they go from nothing to something, and we've got zero time there, okay, because it's the next frame. Time is both frames. The interval is actually the two frames. So you go from nothing to something in no time. One frame of the movie to the other. How do you do that? How can you imagine it? Not even God can do that. He can't imagine it. But this is what the atheists believe in. This is what the mathematical physicists believe in. And yeah, you have people like William Lane Craig. He's a religionist, and he says, hey, you guys are talking about creationism, and you just want to get rid of God, but that's only because you don't want to admit God. So you come with all this nonsense about energy and becoming mass and so on. You know, it's much easier to say, hey, God did it. And for once, I have to agree with William Lane Craig. I think he's right on that one, right? Okay, and so he says, so I say that all he did, Al-Khalili, he swallowed a tale he was told in college and now recites it. He never questioned it. I mean, doesn't he question this thing? Doesn't he realize there's something wrong there? And if he doesn't, then he's got a real serious problem. That means he's not a rational individual. And he claims that we've gotten all the facts down to the first millionth of a second, even billionth, right, after the Big Bang. Now we need your help and contributions, especially, right, to build a collider the size of the orbit of Pluto to figure out what happened in that first millionth of a second. So that's the story for the beginning of the universe. In rational science, very simple. We don't do tests, we don't do any experiments. We just think. We try to visualize. And the first thing we visualize is that something cannot come from nothing. And in other words, what we say there, the way we say it is, space cannot convert into matter, into an atom, and an atom cannot convert into space. What is space? Nothing. What is nothing? That which has no shape. You cannot have an atom which has shape, or a dog, or an earth, or whatever that has shape, suddenly lose length, width, and height, and convert into nothing, that which has no shape, in zero time. Because it's got to do, at some point, you know, you got one frame and another frame stuck to each other, and here you have something, here you have nothing. So it lost length, width, and height by what mechanism? And if space is nothing, it means it has no borders, it has no shape, no boundaries, no perimeter, then there's nothing to cross. Not even God can leave space because he's got nothing to cross when he tries to leave space. So it's very simple. If an object cannot convert into space, and space cannot convert into matter, into an object, into an atom, that's very simple. Matter is trapped, you can say, within space because space has no borders. Even God is trapped here. Everything is trapped here because there is nothing in which we are in. We cannot escape space because space is nothing. Space is not a container that you have a wall and you can go on the other side of that wall. Space is absolutely nothing. And so if an object cannot convert into space and space into an object, matter has always been there. It's always transformed itself, modified, atoms go here and there, but it's always been there because it cannot leave and it cannot transform. Very simple. And so, yeah, our so-called universe, I hate that word because people get confused. I'm talking about matter. Matter has always been there. Matter was not created. Matter cannot disappear and convert into space. Matter has always been there. In that sense, you can say the universe, if you're going to use that term, is infinite in time in both directions of time. It was never created. It will never cease to be. It will never matter will not disappear. There will be no big crunch.